Hey, I'm Alan Furstenberg,
And I'm Mark Tucker. Welcome to Two Voice Devs.
Two Voice Devs. How's it going, Mark?
It's going just fine. Good to talk to you again in this new year.
Always good to talk to you and looking forward to this new year.
Yeah, definitely looking forward to lots of things are going to happen, and we'll be here looking at them and talking about them and sharing what we can figure out.
Yeah. So you were telling me about something you're playing with. I hadn't heard of it before, so I'm really interested to hear about it this evening.
Sure. So this is an open source framework called Parlant, and it's got some interesting things. I think we'll get to the different things as we come up with them, but we've kind of touched on some concepts, and this framework's a little bit interesting, kind of different than a lot of frameworks that have to do with agentic AI than I've seen before. So I thought we could kind of do an introduction, walk through some of the different documentation, some most recent changes in a version 3.1 that was announced, and just kind of talk about some different concepts. Generally, how Parlant does it, and also how that topic affects agentic AI.
Okay.
So I'm on the parlant.io screen. So like I say, this is an open source project. You can access it or create your own agents using Python, and you can access various different LLM models to do that. And we're just going to kind of walk through some of the basics of what it is, and we'll kind of make allusions to how that might relate to something like LangChain or LangGraph or some of the other frameworks as we go. So I'm going to go here to install and just walk through some general topics. So one of the first things that it talks about is something called journeys. And journeys are kind of like flows. So you think about, something in like LangGraph where you very specifically say this is a checkout flow. So it's got this step and this step, and you need to ask for these certain things, etc. So that's the concept of a journey. Though it's not quite so rigid, I guess, as a flow. It gives you the same general, path of as a flow of these things have to happen, but it's not so worried about if the order gets slightly out
I'm
of
thinking
order.
about this in terms of what conversation design used to be like back in the
Yeah,
dialogue flow days.
yeah, exactly. You've got like different slots that need to be filled, but it's you could if you talk to this if you have this as a voice agent, or if you have this as a chatbot, if you're talking to the agent and you provide two out of the three pieces of information, it's going to prompt you for the third. But if you don't provide any of it, then it's going to prompt you for the different information piece by piece. So that's
Okay.
kind of along the lines of a journey. That's the first concept. The second concept is something called guidelines. Now, back in the earlier days of LLMs, we would create a prompt. It was kind of like the master prompt of everything, all the different rules that we wanted this agent to follow, and just have them in one place. And it was kind of like every rule was always present. As the system got more and more complex, it's just more challenging for the LLM to figure out which rule to hit in certain situations. Parlant has this concept of a guideline, which you can say this is something that you want to have happen, but then you also can say this is the condition of when it happens. So
Okay.
I haven't really seen that in other frameworks per se, and you can also have different behaviors or different tools, I guess, active during a specific journey or when a certain guideline is met. So it's also not trying to process 100 different tools
Right.
and figure out which tools are the ones that it should look at. So it's a little bit smarter at that.
And and we've talked about how, when I wrote Voodoo Drive, that was an essential component that I had there.
Yeah,
And these days, it doesn't seem like that's a very popular thing that's under consideration. And most frameworks address this by just having multiple agents, and each agent has its own tools. So you're shifting between agents rather than, well, I guess it is very similar to the notion of, a journey. If you're in a particular agent for a journey, that kind of makes sense, but it's a different approach, I
Yeah,
guess.
it is a different approach and kind of their guideline to how many agents you need. They're not saying don't do a multi-agent system, but they're saying let's lean on the mental model that we're used to of like if you were to call in and actually talk to an agent,
Mm,
would that human agent be able to answer all of your questions? And anything that that human agent should answer should be one agent. And then if they have to escalate to, to a manager or to a different department, that might be a completely different person. That would be in a situation where you would transition to a different agent. So they handle the complexity of too many tools. They don't do that with like you said with multiple agents. They try to structure it with these guidelines and with these journeys. And then if it's a situation where you'd be transferred to a different person in real life, then that would be a situation where you might want to have a different agent that transitions over.
okay.
So, yeah, that's kind of the idea. And one of the things that they talked about are motivations in this motivation section. If you talk about that, one of the things that they're concerned about is making sure that if it's something that's really important, that it follows that path or it does those certain things. It's you can write various different types of agents, kind of more simplistic agents, but if it's something in the like area of financial or healthcare or certain paths where you need it to be compliant,
You have strict rules
then
that need to be followed.
yeah,
Yeah.
then it wants to make sure that in those cases those rules are followed. But if it's something where it's just a preference of like maybe giving a different hello message or suggesting something, that might be a lower priority. So it's not going to put all of its effort into making sure that that happens, but it's going to, in the cases where you definitely need compliance to certain steps or things,
Okay.
then it'll do that. So this is just kind of a bigger picture of the different things that it can do. You can define a glossary of different terms. And so when those terms come up, then it knows how to answer or respond with those. We talked about journeys. We talked about guidelines. It's got tools. What's interesting in this diagram is it's giving you kind of a high level view of the flow. When a user says something, then it's going to go through a process of matching which guidelines match what the user had typed, also based on what the context or the state of where you're at, and it resolves any journeys. And then it goes to this engine where it can, call tools or figure out context. And then there's different output types. There's a fluid output type, which is your generated response, or you could have, in certain cases, canned responses if that's appropriate for that situation. And then it returns that back to the user. I'll just kind of give you a little bit of view of the code. So it's install the Parlant SDK. This is just setting up a basic server, creating an agent, giving it a name and description. In this case, it's a car dealership one, and then you start. But then you can go through and configure which NLP service that you want. There's lots of different providers that you can use with Parlant. Here's a list of them, including Emcie, which we'll talk about later, OpenAI, Anthropic, Gemini,
The usual suspects.
just kind of, the usual ones.
I'm kind of so two things here interest me.
Yeah.
One is that it talks about it that these are NLP services, so it's using it for NLP, not for like the broader reasoning features that that the big models are purporting these days.
Yeah, so the different like NLP tasks that it can do is it can determine which of the different guidelines it matches. It can determine what output it should generate. It can better understand like which journeys are applicable to a certain scenario. So those are the types of things that it uses which when we talk about MC can be optimized with a small language model. So that's kind
Right.
of, we're going to talk about that SLM once we get to that side of things. But basically you create an agent, it's got a server, you specify which provider, and it includes a testing UI to go ahead and test it. But then you create a guideline. So off of your agent, you can say create a guideline, and this guideline is active when the customer greets you, and then the action is offer a refreshing drink. So it's just kind of giving a little nudge that when this certain situation happens, so based on where you are in the conversation or what the user has typed or said for the input, then it figures out which guidelines are applicable based on this condition, and that's an NLP task, right? Matching what the user entered versus what the condition is for this particular thing, and then it gives some action, which then is going to result in some generative message being returned, and it's going to offer them a refreshing drink in this case. So that's the kind of the flavor of how guidelines work. You have this overarching goal that you want, and then you specify different rules or guidelines of when you hit certain scenarios.
This feels overly simplistic to me, but I I want to see where this goes, I guess.
Yeah, yeah. So obviously this is the most basic example, but one of the things that it talks about in why Parlant was created was this challenge in LLMs doing what they're supposed to do in certain scenarios. And this was an interesting chart because it was talking about flow engines, which is like turn by turn conversation with flowcharts. So that's kind of more the prescribed, flow approach, or these freeform prompt engineering. So those are kind of the challenges that it faces, and has
And,
this
and
interesting chart where it
well, and I
where
think the
it
point that
points
it
it.
make I think the point that it makes about those two is interesting. One is that if you're overly structured, you have too rigid a conversation, and we saw that when we were designing, in the Alexa and dialogue flow days.
Exactly.
Whereas if it's too loose, the LLM could go places where you don't want it to go, or it will
Yes.
hallucinate, or do a whole bunch of other issues here.
Yeah, and then you kind of get in this thing where I will in the system prompt, or even in the the in addition with the user prompt, I would give some details to say, uh, stay on topic, or if you're talking about something else, then try to bring him back. You're trying to code all these different rules as part of the different prompts. Now, in the end, these are going to turn into prompts, but what Parlant is trying to do is that there's different types of prompts. There's a prompt that helps me try to figure out which guidelines match, and then figure out which how that's going to influence the generated response, or which tool to call, or so it's instead of giving all the rules and all the tools, it's saying in these certain situations do this, in these certain situations do that, and you can even inside of a flow, or what they're calling a journey, then you can say these tools only apply during this journey. And so instead of giving it the whole world and say figure out what the next thing to do is, which I think kind of goes where all these different reasoning models are trying to go. It's trying to say, here are different rules, and we'll try to be smart about giving it just the information it needs for the next thing that it needs to do. And that helps it to be more precise because it's got less things that it has to try to worry about and understand to decide what the next step is.
Well, you're right. This is an interesting chart, and I kind of get where they're going with this. Give me your take on this chart.
Yeah, so this is kind of the world, Raza and some of the older things that we did, right, in the conversational AI world, I would think would kind of fit more in this area. There was only a certain, you're influencing, or you're either
They were very intent
prescribing,
based.
yeah,
Yeah.
you're prescribing what the flows were going to be based on what the state was and what the intent was, right? And it was like these, but in the end, if you think about it, what state it was in and what the intent was were like, I don't know, in some ways guidelines or at least rules. Like when these rules happen, then this is this is the intent, this is the outtent that we're going to call, right? So
Man, nobody's used outtent in years
I
now.
know.
Love
I
that
thought you would
term.
like me bringing that
Thank you.
back.
Thank you.
Yeah. So whereas kind of when we started in the LLM based world, especially with LangChain and then like LangGraph, then there were more prompt engineering and context engineering. So it's I guess it's just a little bit of a different approach. It was trying to give all the information and then letting the reasoning model figure it out. And I think what they're trying to say here is there's some ground where we can help code this in such a way that it limits what's being evaluated, so that it can be a faster response or more accurate
Yeah.
in what it's doing
Well,
next.
what it sounds to me, and I'm not, obviously I'm not
Yeah.
looking at the code or anything, but what it sounds to me is that it sounds like they're trying to get the best of both worlds here.
Yeah.
They're saying where we need to use an LLM, we will. Where we just need intent detection and natural language understanding, we will use those. You know, if we're going to be saying practically the same answer every time to a user when they ask this question, we don't need to go search a RAG database. We don't need to take the result of that and feed it into an LLM, and it's just going to, give the same answers.
Yeah.
If the intent of the question is to ask, what hours are you open? We can just answer that question. We
Yeah.
don't need to go through all of this other work. So I think they're trying to find the best of both worlds here, and that makes sense.
Yeah, and and I think depending on in certain cases, like I said before, like finance world or healthcare or whatever. So like when I was doing the chatbot for helping users find prescriptions, there was specific language at certain points or certain things that had to be done, and so
Right.
there really wasn't a large reason or desire to throw an LLM to generate the responses in that case.
Right.
So that's kind of where it's like you've got tools to do different things depending on where you are or what type of flow or response that you want. So that's kind of the and that's where all these different things come in here, like journeys or guidelines and relationships and tools and glossaries, canned responses. All this stuff that's part of this framework. I think that's probably like just a good overview of Parlant itself. It didn't really get into a lot of detail, but what I want to do is jump into their 3.1 release that just barely came out. So because it's also talking about some of it took a lot of user responses and kind of feedback and said like how can we make this even better. So it's talking about even giving more granular level of control. So we're saving Emcie for the last type of thing, but like one of the new features is linked journey. So when you're in this one journey, you can transition to another journey, and like I said, there can be conditions on when these journeys happen or not. So for those cases, like a checkout flow or other finding a destination for travel or things that are going to be pretty these are the steps that you have to follow, these are the information that you need, then you can create them as separate journeys and then link journeys together as it needs to be. An increased matching efficiency on these journeys. It also add additional descriptions to these transitions, and that's once again where the language model is going to use natural language to figure out what the user said, where they're at, and what state applies based on additional descriptions in the guidelines and in the states as well. So that's that. This one's interesting in the fact that there's different levels of behavior, high, medium, or low. So in this case, if the customer is asking about cancellation fee, we're going to disclose that there's a $50 cancellation, charge, right? And that's going to be high, in which case it's going to put the effort into making sure that this one is appropriate. Now, something that's kind of low is that if the conversation's just started, you might want to, tell them about items that are on sale. Now, if that gets missed, that's not critical. It's not like nothing's going to fail, but this is a bigger deal with the cancellation fee. So that's where it's talking about criticality levels and how you might want to apply those.
An interesting approach. Okay.
Yeah. So then there's also handlers that when a guideline, when you create a guideline, in this case, you can say, call this function when it matches, but before the language model is called. So you could then kind of nudge it, right? Do something.
I'm chuckling because this seems an increasingly common thing is to have these kinds of hooks.
Yeah.
Showing up before and after
Yep. And here's
an
the
LLM is
unmessaged.
invoked.
Yep. Which is, that's the type of thing that I was used to doing in Java, where you like before, I could capture anywhere along the pipeline of like the message came in, but before before the intent detection
Right. Yeah.
happened, or before the data, the state was saved for the user, or there's different points where you could intercept in this pipeline. So that's something else that was added. This is interesting. Custom matchers. So by default, Parlant uses LLM-based guideline matching, but in some cases you might want to use something like regex or some not even small language model, but like
Right.
something
Where you don't
really,
need to hand it off to to an LLM at all, but you have very specific numerical checks. For example, is this value greater than 100?
yeah.
Yeah.
Exactly. So those are the types of things that you can do, and the examples they gave were you could use embeddings for similarity. You could use regex. You could use smaller models. You could use whatever you wanted in that case. So that would also could be very custom specific to your use case, your agent that you're creating, or it could be to help with latency or costs of the model or whatever. Okay, so the last part that I wanted to cover was talking about their new offering. So this is a paid, everything we showed you up to this point has been open source, but they've come out with a paid product called Emcie. Emcie was one of the options in our natural language processing. So instead of using Gemini or OpenAI or something as the language model, they've got something that's kind of more custom to help how Parlant works and analyzes things, and hopefully to save you some money and increase your accuracy. What it's talking about is, so you immediately start seeing credits, and you see like pricing. So they've got two different models, and it's how much it costs per input token for million input tokens or million output tokens. And there's a Jackal model, which is kind of general purpose, and the Bison, which is like more heavy duty. So it's a bigger model. You're like, okay, well, what does that have to do with things? And then it's like, well, here's some comparisons. Like how would Jackal and Bison compare to something like a GPT-5.1 or Gemini Flash? And this is based on like how complex you think the agent's going to be. So like if it's, in this case, 5 journeys or guidelines, kind of in this case, the middle of the road, that it's actually cheaper to use Jackal and Bison. In some cases, it's, for like comparing Bison to Sonnet, then it's, a third of the price, basically, right? So what does all that mean? So that's kind of where we're going to jump into this next section here. So there's two things that they're talking about. There's model tiers, which which was Jackal or Bison. So if you're doing something that's kind of lighter weight, maybe just a simple chatbot type of thing, and you don't need the extra horsepower or whatever of a bigger model, then you would use Jackal. But if you need that extra power, then you would use Bison as the model. Now, I do have some questions out to the creators of this, because I want some more specific answers on how those model tiers work and how the roles work. But just generally, Bison's more powerful and heavier model than Jackal is.
I guess my first question is, okay, does that mean you need to use one of the models for everything? Or I guess that's where roles come in. Or I hope that's where roles come in.
So I'll talk about roles, and then we'll talk about. So in each of those tiers, it follows a teacher-student architecture. So what it seems like from the initial reading of it, the teacher is kind of the large language model, and the student is something that gets generated over time based on that teacher model and your
Okay.
output. So this is more of a small language model that's optimized based on the actual usage of the agent. Kind of like a bigger, this talks about generally what the optimization challenge is. You want large language models, but you don't want the cost of a large model, or you don't want the extra latency that you get from a large model when you don't need it, type of thing, right?
So this is a concept. If I'm reading this text correctly, this is a pretty common concept when building small language models. It's this concept of transfer learning.
Yeah,
So you don't necessarily need to teach the small model everything. You're just teaching it some specifics, and you're using the large model to help train the small model.
correct.
That's a subject we
So
should probably talk about one of these days, all on its own.
there is two different options, or two different ways that Emcie. So basically, you're pointing your agent to Emcie as the engine, and it's doing stuff behind the scenes for you besides just inference, right? So one of the things that it can do is dynamic prompt optimization. So generally, the prompts that you've got are handled in a generic way, but the prompts themselves can be modified over time based on what your agent is actually doing or how you have your agent configured. So one of the ways that you can, in essence, this isn't fine tune, you can, I guess, just optimize. The way that you can optimize how accurate your agent is by just using it and taking, some of those outputs and figuring out what it's actually doing, and then optimizing the prompts a little bit more so that it's tailored it more towards what your system is. But then, like, when something happens and you change the configuration, then it's got to do some additional work to make sure that that's factored into the whole thing as well. The second thing that I can do is to distill a small language model, using fine tuning and the responses that you get based on the teacher model. So the student model is the small language model, the teacher model is the large language model. So there's this period called the grace period. So when you first start using Parlant against Emcie, everything is being sent to the teacher model, and it's figuring out what the outputs are and saving that as a data set. And over time, after this grace period, I don't know, 100 different, conversations or something, along those lines, then it's going to start switching over where it's going to use the cheaper, well, it's going to fine tune and optimize, and it's going to go ahead and change over so it's using the student model. So the idea being is that when you're in development, just use the teacher model. Once you go to something like staging, you can switch the flag to auto, which means it's going to use the teacher model and start this grace period and go ahead and start creating this student model for you. After that grace period, then you could move that into production and either just always use the student model or also have it be auto. And as things change or configurations change, then just the new stuff gets updated
So
in the model.
So what I catch here is this line: once validation passes, requests begin routing to the student, and your costs decrease.
Yeah, because if you look at,
I get why your costs would decrease.
yeah,
My question is, when you looked at the pricing page, it didn't say anywhere, here's what over time, here's what the
yeah.
price is going to be when you begin, here's what it's going to be later.
Let's see if it says it here.
I mean, does
So here's Jackal, where the teacher model is $1 per million tokens for input and $8
okay.
per million tokens output. But then over time, when it switches to the student model, and I think, and I'm not sure exactly how they calculated it on that pricing comparison tab,
That
how,
pricing comparison tab was just showing the student price.
was it just the student price? So does it say,
And it's
yeah,
saying,
well, terms show apply to student roles. Yeah,
okay,
you're right. So yeah, it would be interesting to do a comparison about how, how this exact pricing compares. But
well, it's interesting because to me, what this is saying is your message accuracy is going to be higher because we have trained it on your messages.
yes, and the latency is going to be lower because it's a smaller model with
Right.
less parameters.
It's, I mean, it makes total sense and it's an interesting approach. What I kind of find interesting though is, they went and compared it against it's price competitive to the older Gemini models. I'm curious to see how price competitive and how technology competitive it is against Gemini 3.
Yeah,
And I don't have the answer, obviously, but
yeah, yeah.
it's interesting. It'll be an interesting question.
Yeah. So the question that I had when we were talking about these different model roles being the teacher and the student was, is the teacher just a standard large language model, whereas like when you're talking about like GPT-5 or some other models, it's kind of like a model that calls other models, right? It's kind of a router where it determines based on what the query is, what it
Right.
comes now. It'd be interesting to know if that's true, if this is just like a kind of a single purpose LLM, or if it's kind of a router multi-based, because I could see different NLP tasks requiring different power
Yeah.
of different things. And so, or if there's a way to like say in this case, well, there was a way that we could say in this specific case that it's going to use not use an LLM or use a different model to determine generation matching. So it does give you ability to use different models for different things, even if you're using like one main LLM for something, right?
What I'm kind of curious about is if this model is available without using Parlant. Can I just call this model directly?
That is interesting. I don't know.
Because,
So
uh, you know, because otherwise, I mean, if I cannot, that suggests to me that yes, it is three models in a trench coat.
yeah, it's a special purpose model that is really
Right.
geared to Parlant, right?
Right. And it's, geared to the very different ways that Parliament may be doing things. So it may have, a tuned version for each one of those, or it may not.
Yeah.
But it's very specifically tuned for what Parliament is trying to do and may still be a large language model.
Yeah,
So
I'll have to
it's,
look at more at the documentation and if it talks about how
it,
you would use the model standalone outside of
right.
Parlant, or if it is,
It, it does say optimized for Parliament.
yeah.
So I don't know. Interesting question.
Yeah.
And mind you, I don't think that's necessarily a bad thing, but it's interesting.
Yeah. So, sure, we went through and we kind of introduced Parlant, which was a new framework that I think a lot of people may not have known about. It does things kind of in an interesting way, a little bit, different than what you would see in something like a LangChain, LangGraph, or agent framework for OpenAI, or even Microsoft Agent Framework, or it does things kind of different. And we talked about how not everything is active at any certain time. So tools aren't always all live. All rules aren't always in context, type of thing, which is interesting. And then how it is trying to use optimization and small language models to get great accuracy for a lower cost and less latency.
So really interesting. I'm curious to see if other people are working with Parlant. How did you discover this, by the way?
Just actually came across it on LinkedIn, and so I've looked at it a few different times. I think I hit the 3.0 announcement a couple of months ago, and just have kind of kept my eye on it and played around with it a little bit. But it just sparked a couple of different things that we had talked about previously that I thought, this is interesting. This kind of tries to
Yeah.
address some of those things that we talked about.
So I'd love to hear, what other people think about this, how you're solving some of the problems it may be addressing, or what your experiences may be with small language models or anything else.
Yeah.
As always, you can reach out to us on social media. Don't forget to like, subscribe, and share. And we will talk to you another time on Two Voice Devs.
Two voice devs. Thank you, Alan.
Thank you, Mark.